controller.
Very good. Where's my control?
There's a controller, and let's make sure
It works?
well, that you know how to operate.
Okay, so what do we do?
I think it's that one. There we go.
Yeah, good.
All right, great.
Good, okay, so let's make sure everybody's not too low in their chairs here, an hour after lunch. So we're talking about solar, so we got to get ready for it. How many people here have solar on their house? Wow, it's about 5. That's big. So we're not talking about solar on your house, but we are talking about solar energy, and we are talking about converting a part of the capacity for electrical generation to solar. What Skyline's about is solving the big problem that solar costs too much. Why don't we have more solar? Because it costs too much. How can we go faster, cheaper, better? How can we scale this industry up? If you want to build a gigawatt fab, you need over $1 giga. Simple. And the financial markets have not been kind in putting down big gigadollars in the last year or so. They did make some big bets a couple years ago, and some of them are working out and some are not. With the Skyline model, you can put up a gigawatt fab for about $150 million. How do we do that? I want to show you how. We can generate electricity about 26% cheaper than the current trend line. I want to show you how. So I'm going to show you our product. We are a systems company, not a chip company. So I worked for Intel for 22 years. This is not Intel. So we're more of an HP, putting a system together, selecting the best components available, integrating them, rolling them out in huge scale. We are an IP company. We have 6 issued patents and 20 are further applications. 5 of those 6 were through the CleanTech Fast Track program. In fact, we became the poster child for the CleanTech Fast Track program because we got through the first patent first. So let's carry on. We do have some funding. NEA has been an excellent investor for us. We did win a development contract with the DOE for Solar America Initiative to speed our first product into production. We got that contract in 2009, got into production. We did, in October of 2010, win a DOD contract to put up some starter projects, one at Fort Bliss, which we'll be building this year, and one at Edwards Air Force Base. And we have won the first phase of a 10-megawatt plant in Durango, Mexico. And we have also projects under development in India and in Italy. We'll be having a partnering strategy for a lot of that activity. So what's the measure of a PV system? It turns out it's this magic number called LCOE. What does that stand for? Levelized cost of electricity. Basically, the total lifetime system cost divided by the total energy value that is generated, divided by net discount rate and so forth. And what you can see here is 2 technology lines, flat plate and the thin film, and their line. With Skyline, we can reduce those. And we have 2 flavors, so we can go down even lower in cost. And we have a roadmap to even accelerate that over time. This is this year's cost. What we see across this, obviously the sunnier it is, the more the payoff is. How do we do that? There's a panel here that has 72 cells on it. We take equivalent of 3.5 of those cells, chop them up into pieces, and put them on our own special CPV panel right here. Then we put that onto a trough that looks very much like a CSP trough, using and leveraging the same glass industry that the CSP industry uses. Same vendors, same bankable glass. There you can see the actual sunlight on our 3.5 cells. Obviously, we have a lot of money saved from not buying those other 69 cells for each 180 watts. Then we track the sun, and there's one of our systems that's about a mile from here. And I invite anybody to come and give me a call, and I'll show you the actual system. We're going to lower cost and get bigger scale. That system is 40 feet long and 9 feet wide. This would not be a system that would stand on your roof. This would stand in a couple of hectares per megawatt. And it would be in long rows like a CSP row. CSP stands for concentrated solar power. Same kind of mirrors, but in the middle is hot water. Here, we don't require any water. Therefore, we're better than CSP. We can also upgrade. Here's your standard flat plate panel system. Over here, you see a Skyline system. when we have our 24% and our 28% panel, we can upgrade that system and get more power. You see those little ups? We'll get more power over time out of the same system for your perennial power plant, because these systems are going to be in the field generating power forever. We've got systems deployed in Europe, Hawaii, California, Arizona, and we have a manufacturing strategy with these partners. We're leveraging the metalworking industry, the mirrors, and other contract manufacturing. For 15 cents of CapEx, we can build a watt of capacity. Then we deploy, and actually all these parts don't even meet until they're built in the field. So a lot of our strategy is logistics and systemization behind that. We've got a Class A management team. We've got Tom Roars as our CEO and chairman. He had been a SVP at Applied, Silicon Graphics, and so forth. Bill Keating was our co-founder. He's a board member and participated in the founding of Soul Focus. And he's our VP of Sales and Business Development. Bob McDonald's our CFO and our CTO and co-founder. Jeff Osario, public-private, myself, and Danny Chung. There's a summary of our strategy that you can look at while we do questions.
Thanks, Tim.
Talk a little bit about the installation costs and what's necessary to put a system up, how long it takes, what you would assume that would cost you on a dollars per watt basis.
So for a driven peer solution, we have it right now in part of our DoD contract. We're proving this at $1 a watt, including the inverter. And we think we can get that down to 80 cents. We've modeled it in Rajasthan, where I have a developer right now wanting to do it there for 64 cents, including inverter.
So the projects, you have 4 of them, I think you mentioned. What are the IRRs of those projects, if you can share?
As you know, so the early stages, we have 3 of those are investor-owned. So in other words, somebody built those projects, they own them. One of them is developed by ourselves. Those are the ones that are in the ground right now. They're all basically test sites. 2 of them are producing revenue on a PPA, but they're all producing benchmark data for us. And we've had Black & Veatch crawl over everything. Because without a couple years data, really a year at least, it's hard to get an investor to plunk down money, even though we're very low risk with silicon cells, which are proven, glass, which is proven, single axis tracking, which is proven. So each one of those sites is returning data right now, and it's a very high rate.
What's your model, though?
The model?
Yeah, I mean,
we can compete depending on all the same financials. With the LCOE I showed you in a 20% model, in Rajasthan, we modeled out at 18%. We're modeling programs in southwest of the U.S. right now at 15%.
Okay.
Questions?
So the solar industry is going through a lot of change. Costs are coming down with a lot of flat plate guys, and that seems to be what's been happening, at least in the last 5, 10, 20 years, right? So I think your costs look great today, but how do you see that in a 3 to 5 year time frame, especially with a lot of the cost reductions that are happening in China and so forth?
So let me tell you what happened over the last 2 years, because we've been working on this model for 2 years. In the last 2 years, the panels have more or less dropped in half in price. What did that do for us? That moved cells from this high in our Pareto, the top number 1 start, even with only 3.5 per panel, down to about here. So when cells come down in price, we like it. Why? We're not buying experimental science cells. We're buying middle-of-the-pack, high-efficiency monocrystalline cells. So when those come down in price, we benefit from that.
But the rest of your bar doesn't change nearly as much, though. So
but that's where our IP comes in. So our first system was at 7x. This one's at 14x. And there are systems deployed on silicon out to about 200x. As you go up in concentration on silicon, you actually get more output. The other thing is what's happening is we're leveraging the billions of dollars that's going into cell R&D. So 2 years ago, it was almost impossible to get a 20% cell. Now I have 5 vendors qualified, 2 which we're going to go to business with. So we are just going to leverage that. So when 24% cell is not strange and wonderful, it's middle of the pack, we'll move up to that. And actually, that was the first bump on the upgrade strategy I showed you with a 24% cell.
So on that retrofit, so at the point that you put a new technology on, you're basically writing off the initial cells that were on, the initial panels that were on.
Right, it's 1 minute change.
Right. So what? But you're also you're buying a new cell that then needs to go on.
Right.
What does the change in efficiency have to be in order to make the economics?
We like 5%. We think that can give you up to a 50% bump in your IRR. Think about it, though. You have a plant in the field that is producing electricity. It's got grid connection. The sun is shining. The power is needed. It's going to be producing power there forever. You ever try to move a utility pole? They never get moved. They're there forever. It's a utility. That's a utility. It's going to be there forever. That system's going to get upgraded whether it's Skyline or not. In our case, we're going to be the low-cost upgrade. Plus, that panel's written off already.
Excellent clock
Done.
management, Tim.